So let's suppose you open a lemonade stand to make some extra money on the weekends. It costs $350 to build the stand and set up your location, and 85 cents per glass of lemonade, which you're going to sell for $1.55 per glass. Then, what we want to do is write the cost and revenue functions for the lemonade stand and find and interpret the break-even point for the stand. So with this, we are coming back to where we started essentially, because we have our cost function here, Cx is equal to 0.85 plus 350, and Rx, oh, get the x in there, close enough, is equal to, without smudging too much, 1.55x. Where I picked the lemonade stand here, even though people probably don't really use lemonade stands anymore, because I want to make something fit those small numbers, and I didn't want the graph to look too ridiculous for this. In reality, for a company, you're probably talking about like 1.5 thousand or million or even billion dollars, depending on what product that would be there. But trying to keep things on the micro scale rather than macro, just to make it look somewhat reasonable in terms of a picture. I don't know. It's not big money yet. Anyway, with these, we have our setup in mind, and if we want to solve our system, well, this would very clearly turn into a system of linear equations. Y equals 0.85, there should be an x up there, plus 350, and x is equal to 1.55x. Oh, not x, excuse me. God, my variable's so bad. Y is also equal to 1.55x. And then from here, we solve this however we want to. I wouldn't use addition here, because getting these two things to match up isn't very much fun, but you can actually just do some really direct substitution in this case, because you basically got it already. What we can do here is say y is equal to that value. So our system, via substitution, very directly implies that 1.55x has to equal to 0.85x plus 350, or if we move our terms around just a little bit, we would have 0.7x is equal to 350, or dividing out the 0.7x, x is equal to 500, and then we can plug this back into there to get that y is equal to 1.55 times 500, or 775, which you should have noticed if you're paying close attention to that point on the graph. It should be around there. The scale is not perfect, being able to just eyeball that, but you get the idea here that for the lemonade stand, if you want to break even, you would need to sell 500 glasses of lemonade, at which point it would have cost you $775 to make it, and you would have pulled in $775 in revenue, where every glass of lemonade beyond that is profit. But that's a little bit too simple, right? Even though we introduced these extra pieces to get a little bit more detail in there, there's still a lot more we can talk about, because our systems need not depend on only one pair of things. They could be groups of three things, or things that are not just linear, things that are more complex than that, and that's what the rest of our chapter is going to be about. We're starting off here with the relatively simple case, because even dwarves started small, and we're going to work our way up until we get to some of the more complex types of things we can have with these systems of equations by the end of the chapter. For now, though, we're going to move into 5.2 and look at these same types of things, these roughly linear, although it's more planar, as we'll see in the next section, systems of equations, that is, equations in terms of three variables. That's coming up next.